So here is question number 6. In the arrangement shown in figure, the y coordinate of image of point object O is what? Now here is the point object, prism having angle of prism 2 degree, and next is a convex lens of focal length 20 centimeter. Distances are given. Now let us draw the diagram. Suppose this is the prism. Here is the line on which object is kept, point object it is. This distance is given 10 centimeter. Now let us take two light rays. One will be this, deviated by a very small angle. If this is 2 degree, now let us calculate the angle of deviation as well. We know very well angle of deviation delta is given by angle of prism mu minus 1, where mu is the refractive index. A, that is 2, mu 3 by 2 given in the question, minus 1. Solving it gets you 1 degree. So angle of deviation is very small, that is 1 degree. We can convert it into radian, that is pi by 180 radian. So this is the angle of deviation delta, which is equal to pi by 180. If this is delta, then let us take one more light ray. So it's something like this. Image is formed right here. This is HO. Suppose this is HO, this is 10. Delta, this angle will also be delta, vertically opposite angle. For a very small angle, we can write 10 delta, which is equal to delta, perpendicular upon base, HO upon 10. From here we have got the height of object, that is 10 into delta, that is 10 into pi by 180 or pi by 18. Now let us talk about the lens. This will act as object for this lens. So object distance we have got 20 plus 10, that is minus 30 centimeter. Focal length given 20 centimeter. By the lens formula we will get the value of V, that is 60 centimeter. From here we got the magnification M equals V by U, that is minus 2, and magnification is also equal to minus 2 is also equal to height of image upon height of object. So HI upon HO. From here we have got the value of height of image, that is minus 2 into HO, that is pi by 18. So got the value of height of image, that is minus pi by 9. We have to calculate the y coordinate of image. Now the object is beyond focus, so that's why image will be real, formed below the principal axis. This coordinate we have calculated, that is minus pi by 9. So we can say that option number 2 is absolutely correct. We will go with option number 2 only. Now move on to the next, that is 7 number. Here is question number 7, everyone. Two blocks A and B having masses 2 kg and 3 kg respectively are connected by a massless spring of a spring constant 20 Newton per meter as shown in figure. If coefficient of friction between blocks and horizontal surface is 0.2, then the minimum value of applied force F for which both blocks will be able to move is what? Now I want you guys to focus on this 2 kg block. The forces acting on it, means when we apply the force, it will move due to this spring force. So the maximum value of friction across it will be in left direction, that is mu m into g, and this kx should be greater than mu mg, or greater or equal to mu mg. X will be mu, that is 0.2, m, that is 2 kg. Gravity we have to take 10 divided by k, that is 20. So this block will move if and only if there is the extension in the spring, that is by 0.2 meter. The block will move when a spring will be stressed by 0.2 meter. Now let us focus on block number 1. Block number 1 will move by some distance, and here the spring will be stressed by the same, that is 0.2. So the net forces acting on this block will be this applied force F, the block is displaced by some distance. So let us apply the work energy equation. The total work done will involve in what? Change in potential, elastic potential energy of the spring. Change in elastic potential energy of spring. Now F force, F into X minus friction is also acting on it, that is mu into M into G into X. Work done by friction, work done by applied force. This total work done will do what? Will change the elastic potential energy of spring, that is half kx square. So single x will be cancelled out right here. Now F will be mu mg plus kx divided by 2. Putting the values, mu 0.2, mass 3, gravity 10 plus k 20 into 0.2 divided by 2. After solving, this net force or applied force comes 8 Newton. So the block will just start to move if the applied force is 8 Newton. We will go on with option number 3, which is absolutely correct. Now move on to the next, that is 8th number. So here is question number 8, everyone. A ball falls from height h over a fixed inclined plane of inclination theta as shown in figure. If after collision the ball moves horizontally, then the coefficient of restitution is what? Now this height is h, block started to move. Suppose the speed right here is u. Now this will be the common tangent and this will be the normal. The velocity never changes toward the common tangent. While hitting, suppose the speed is u, therefore this will be u and this is given by 30 degree. The component of u can be given as, this is u cos 30 degree, and toward common tangent it is u sin 30 degree. Now if coefficient of restitution is e, this velocity is u cos theta, then after collision this component is given by e times u cos 30 degree. E times u cos 30 degree. The resultant of u sin 30 and u cos 30 is what? In the midway. This is the resultant velocity after the collision. So we can draw it this way. I am taking it along x-axis, I am taking this along y-axis. This angle will be 30 degree. I can rearrange the diagram. This is suppose x, this is suppose y, and this is the resultant direction of velocity. Angle 30 degree. Resultant is making 30 degree with x according to diagram. So along x the speed is u sin 30, along y it is e times u cos 30. So if this is y, this will be also y. So we can write tan 30 equals this velocity component upon base, that is eu cos 30 upon u sin 30 degree. U cancel out, tan 30 equals e times cot 30, or e can be written as tan square 30 degree. After solving, tan 30 1 by root 3, tan square 1 by 3. So the coefficient of restitution, that is e, given by 1 by 3. Option number 2 is absolutely correct. So we will go with option number 2 only. Now move on to the next, that is 9 number. So here is question number 9, everyone. A composite spherical shell is made up of two materials having thermal conductivity K and 2K as shown in figure. The temperature at innermost surface is maintained T1 and the outermost surface is maintained at T2, given that T1 is greater than T2. the effective thermal resistance between the inner and outer surface of the shell for radial heat flow will be what? The arrangement is in series, so effective thermal resistance we can calculate. Effective thermal resistance R. This R is not radius, mind my words. This is effective thermal resistance. Let us call it R effective. Will be given as R1 plus R2. Now this R1 can be calculated as, we know very well, R is given by L upon K A, where L is length, A is area, K is thermal conductivity, which is given K and 2K for the structures. Now considering this as dx, a sphere having radial length dx at a distance x from the center. So R1 can be written as, for this small element, the thermal resistance given as length small dx divided by conductivity k, area 4 pi x square. So this is for small element dx. So for total inner sphere will be given as from R2 to R. So this is your R1. After integrating and solving and putting the proper limits, we can get this as 1 by 8 pi kr, where r is radius, k is thermal conductivity. Similarly, we can calculate R2 also. In order to calculate the R2, we have to take a small element of length dy at a distance y from the center. So the thermal resistance, the small thermal resistance due to this small element dy can be written as length L, that is dy upon conductivity 2k into area 4 pi y square. Now this is for a small element. Now for total outer sphere we can take the proper limits, that is from 2r to 3r. After integrating and solving it, we will get the value as 1 by 48 pi k into r. So now we have to add these two values, and now we can get the total effective resistance R effective, that is 1 by 8 pi kr plus 1 by 48 pi kr. Putting the values, we will get 7 divided by 48 pi kr. So this is the total effective resistance of this structure. So after looking at the options, we can say that option number 2 is absolutely correct. So we will move on with option number 2. Now move on to the next, that is 10 number. So here is question number 10, everyone. An audio signal is modulated by carrier wave of 1 MHz frequency such that bandwidth required for modulation is 2 kHz. The value of R and C of diode detector such that this wave is modulated by a diode detector would be what? Now carrier frequency given as 1 MHz, we can calculate the time period, that is 1 by Fc, which is equal to 10 to the power minus 6 second. Bandwidth given as 2 kHz, and we know very well bandwidth is equal to twice of modulated frequency. So from here we will get Fm, that is 1 kHz. The time period of modulated wave 1 by Fm can be written as 10 to the power minus 3 second. Now why we have calculated this time periods? We know very well for diode detector RC product, that is R into C, would be much less than time period of modulated signal and much greater than time period of carrier signal. So we know very well for diode detector, the product RC must be much less than time period of modulating signal, and this RC must be much greater than time period of carrier signal, that is 1 by Fc. Now looking this particular thing into mind, we have to get the most appropriate combination of R and C. Move on to the first number. R is 10, C is 0.1. So you will get the value of RC as 10 into 10 to the power 3 multiplied by 0.1 into 10 to the power minus 6, that is 10 to the power minus 3. Now RC should be much smaller than 1 by Fm, but here RC is exactly equal to 1 by Fm, so we cannot take this option. Move on to the next. Second, R and C. For second option, the value RC we can get 10 to the power 3 multiplied by 0.2 into 10 to the power minus 6 gets you 0.2 into 10 to the power minus 3 or 2 into 10 to the power minus 4, which is smaller than 1 by Fm. Now this RC is also much larger than 1 by Fc. Option number 2 is satisfying the criteria, so we can go with option number 2 also. Let us check another options. Here RC, that is again you will get 10 to the power minus 3 equal to 1 by Fm, which is we cannot take. This is also we cannot take because the first will be satisfied but second will not be. So that's why we can say that option number 2 is most appropriate. So we will go with option number 2 only. Now move on to the next, that is 11 number.